Hello, everyone. Welcome to the Public Global R&D meeting. I'm Saša. I'm a team lead of the Decentralized Reliability Engineering at DFINITY, and I will be your MC for today. We have a couple of updates and then a few demos that we thought might be very interesting to share with the broad IC community. Since the last Public Global R&D a month ago, the IC ecosystem kept growing and maturing, and we will try to briefly summarize and mention some of the developments that happened in the last month. Of course, we couldn't fit all the developments that happened in only 1 hour video, so we will provide a handpicked selection. Hope you like that. Hope you like that. We hope that this will provide a valuable insight into the new and upcoming things in the IC ecosystem, and not only what the DFINITY Foundation was working on in the last month, but also the broader IC community. To get going, in the update section, we have first an update on the IC ecosystem metrics, which were prepared by Kyle Langham, which I will share with you since he's not available today. And then we will have an ecosystem report by Radu, and finally, developer experience update by Jason. And then after that, in the demo section, we will hear about the following. First, Leon will demo new canister status extensions by the canisters. This was a popular request by IC users. And then Björn will provide a sneak peek into the NNS Neuron Sandbox, an interactive simulator for the NNS neurons. And then Timo will provide a new high-performance multi-token ledger. And finally, we'll have a community demo for Helix Market SDK. All right, so on the metrics update, since this week Kyle is at the Ethereum conference in Denver, I will share the slides that he prepared, so all the credit goes to him. The metrics section this time is focusing on CKBTC, and particularly its growth in the last 3 months. This slide highlights how CKBTC supply has grown significantly in the past 3 months, and CKBTC is now the 7th largest cross-chain asset according to DeFi Llama. This slide is focused on how CKBTC transactions per day and volume per day have both grown significantly in the past 3 months. Volume per day increased 650%, or equivalently 6.5 times in the past 3 months, relative to the prior 3 months. And transactions per day are also up 640%, or 6.4 times in the past 3 months relative to the prior 3 months. So this is a very, very significant growth in the usage. And then analyzing boundary node activity to the CKBTC canister for ICRC1 transfer calls. From the calls we can attribute to an app, Bionic leads with 44% of all CKBTC transactions. Then IC Lighthouse makes up an additional 22%. Plug makes up 19%, and NNS makes 7%. Overall, CKBTC growth seems to be just getting started. There are many tailwinds to drive further growth in 2024, including broader market trends towards the Bitcoin economy and ICP-specific verticals, including ordinal and NFTs and CK World, which is the ability to swap between cross-chain assets cheaply and easily, and more broadly, general usage in social apps. So yeah, a lot of good things are happening around the CKBTC world, and we are very eager to see what will happen. All right, and the next will be Radu with the ecosystem report.
Thank you so much. Hi everybody. I'm Radu. I'm from the growth team, and today I wanted to take the next 5 minutes to present something that we have been working on for the past months, and that is the ecosystem report. So what it is basically something that we plan to have on a regular basis. It's probably going to be biannual, so we'll have two of these each year. That showcases that. So each report will showcase the latest and greatest from our ecosystem. Whatever has happened in the past 6 months, that is exciting. What are the new projects that are building on top of ICP? What are the new grantees? What is happening inside the ecosystem? What are the new trends that our ecosystem partners or our ecosystem, our community kind of see as happening going forward. Then, yeah, the report will also feature the latest SNS swaps. So whatever happened on that front as well, any notable grantees, and of course the top initiatives from the hubs. The current ecosystem report is the very first one, and it features community contributions. So we have pieces that were authored from Blockchain Peel, and also a very nice piece from Bob from Bionic on the outlook on the Bitcoin ecosystem going forward in 2024. Why we decided to do this is because we thought that we need an avenue to give updates on what is happening inside the ecosystem. And sometimes just social media is not enough. We just wanted to have a condensed way in which we show, okay, in the past 6 months, this is what happened. These are the trends. This is what is being built. And moreover, we just wanted to showcase the success stories, because sometimes we feel that whenever we're talking and we're engaging with partners from outside of our ecosystem, they have troubles kind of seeing what the depth of the activity that is happening on the ICP ecosystem. So that's why we thought that having a report that goes in a cadence and just showcases the success stories from our ecosystem makes sense. So now the first report will be published next week, but I just want to give a quick sneak peek for everybody. So yeah, we start off with this piece that is an introduction that is coming from Kyle, and has helped me with this basically introduction and kind of what has happened in 2023 in terms of growth related to the ICP ecosystem. We have the facts and figures related to grants and hubs and everything that is exciting about the ICP ecosystem. We have an article on multi-chain DeFi, kind of how all the DEXs on ICP are approaching multi-chain and the benefits and what they see as an advantage for and why they built on ICP. Then we have this article from Bob, who is looking at what is in store for the Bitcoin ecosystem going forward in 2024. Which I encourage everyone to read once we release this. Then we go through the notable SNS swaps, which, being the first report, is actually covering most of the SNSs so far, showcasing to everybody that is interested in the ICP ecosystem that, okay, these are the cool projects that have decentralized their governance through the SNS. Then again, I would like to thank Blockchain Pill for helping me with this article on dragons. And then if you want to see kind of what has happened with the developer grants, what are the notable grantees, some of the hackathon winners, what they are building, how they're building it on ICP, you can of course have a look in this report. And all of them are grouped by verticals. So you can see kind of the activity going on in multi-chain and DeFi, or gaming and metaverse, and all the others. And of course, we have the activity from the hubs, with a few notable hubs that are being featured and their most notable achievements in the past year. So yeah, thank you very much for your attention. The report will be released next week. we plan to have this on a regular basis. And once you read it, I'm looking forward to your feedback. What do you think we should improve? What do you think we should include in the next reports? So thank you very much, everybody.
Hi, everybody. I'm Jason, engineering manager here at DFINITY, and I'm going to talk to you a bit about developer experience, what we're doing, and where we've come. So a brief recap. Let me start with that. Next slide. We launched dx.internetcomputer.org back in April of last year. You might know this as the feedback board. So our goal at the time when we started this project was to figure out how to understand and better prioritize good developer experiences across our products. We knew that in order to accomplish that, we had to listen to the community, listen to developers. And so the feedback board became the place for anyone to create topics and discuss the improvements they wanted to see. Next slide, please. So 10 months in, I'm happy to report a few key stats. We have 215 topics created, 580 votes in total, 173 issues that are currently open. We have 6 issues that are currently in progress. And lastly, we have 32 issues that have been completed. And I think that this is a pretty big milestone because what it shows is that in 10 months, we've addressed roughly 3 developer experience related issues per month. And I think that response is resulting in a lot of improvement for the tooling and really the ICP stack in general. So looking at everything we do through the lens of developer experience has now become a standard practice for engineering at DFINITY. And this is great for a number of reasons. Next slide, please. So let's talk a little bit about what we've completed in the past 10 months or so. Number one, you asked for a way to easily switch between different DFX versions. So we launched the DFX version manager just last month. Next. You asked for more conveniences in text in Motoko. So we added the 2 lowercase and 2 uppercase methods. Next. You asked for a way to deploy code without a wallet. So we created the deploy to playground functionality. Next. You asked for a way to know if a caller is a controller in Motoko. So we added that method in. Next. You asked for larger WASM uploads. So we made it so you can upload large WASMs in a chunked fashion. Next. And there are many more. There are many more minor improvements across the board. You know, we've sort of looked at everything through this lens of developer experience, and in some cases, it's challenged us to rethink parts of the protocol, and it's in the case of Motoko, it's challenged us to rethink some of the aspects of the design of the language. So I think this has been a really great experience for us so far, and we're going to keep doing this. So if we go to the next slide, please, we'll see that we have a few issues that are currently in progress. So the cycles ledger is nearing completion. It's currently in progress, and if all goes well, then I have a presentation for you next month. What else is in progress is better Rust and Motoko interoperability, including the ability to call Rust functions in a Motoko program. We're working on this at the moment. We're working on system level logging so that you can log traps in your canisters. We're also looking at canister state snapshots. Let's see what else. Seamless orthogonal persistence in Motoko programs, and more to come. Of course, you saw in the previous slide, we have 173 issues that are open. So we're going to continue to pull issues that are in that developer experience category, and we're going to continue to prioritize and work on them. Okay, then next slide, please. So to summarize, ultimately, we our goal is to create products that bring joy to developers, to the developer experience. So our commitment to you is to keep listening, to keep improving. And one thing that you can do to help us is to vote for the topics that you care about or create your own. There's a link here, the QR code, dx.internetcomputer.org is the feedback board. And I will report back next month on more DX updates. We'll do this on a recurring basis in each Public Global R&D. So yeah, thank you very much, and back to you, Saša.
Thanks a lot, Jason. Yeah, I think it's great that we have a board where users can actually vote for things. But yeah, it's great. All right, so let's jump to the demo section. Leon is the first one.
Yeah. Hi. Yeah, hi, I'm Leon from the Consensus team, and I will be presenting a new feature that has been in the works called Query Statistics. So what is Query Statistics? It's a new feature that allows canisters to get insight into what's happening on the query calls that it serves. In particular, it records the number of calls, instructions to serve these calls, as well as request and response bytes served by the canister's query calls back to the canister. So this can be used by a canister to get some introspection into how popular it is, how many query calls it serves. So decentralized analytics. Potentially in the future, we also might want to use this to charge for query calls. However, this is outside of the current scope of this feature. And this feature is implemented through extending the canister status endpoint of the management canister. Next slide, please. Why do we need this feature? So unlike update calls, query calls are served by a single replica. It's non-replicated, it's read-only, it does not manipulate the state. So from a canister's point of view, it's quite hard to see that a call has actually happened. So in this example that I'm sketching here, we have a subnet with 4 nodes. We have a boundary node. Queries are coming in through the internet to the boundary node. The boundary node spreads these queries among the replicas, and the replicas serve them. However, those are different queries. So the statistics that they generate, the instruction counter and so on, they are not the same. Those are slightly different, and every node has their own local view on the query calls that they serve, but there is no replicated view yet. So for a canister, this information is not usable as it is. Next slide, please. So what we then do is that after some fixed period of time, all the nodes send their statistics that they have collected through consensus, and then it gets recorded into the state. And once we have sufficiently many entries in the state, we will calculate the median of these values. In this example, I just showed for the instructions, but it works similarly for all the other statistics. And these median values is then what gets recorded into the canister state and can be used by the canister. Next slide, please. So this is how you use it. It's quite straightforward. On the left, I have a snippet of Rust code where you can see that yeah, it's essentially just a call to the canister status endpoint of the management canister. And then there's this new subfield called query stats. And on the right, I have given some example outputs. So there are currently 4 different statistics being recorded. And those are essentially counters that just go up, and you can regularly query them and use them for your internal analytics. Next slide, please. So this feature, this approach has some limitations. So it is important to note that the information that is provided is very coarse-grained. We have 1 set of statistics per canister, so there's no possibility to track information on a per call basis or which endpoints are actually being queried. It's also important to note that there's a considerable delay between the time when the queries happen and when they get persisted. This is because an epoch, this period of time that we use to record the statistics, will be approximately 10 minutes, and it might take up to 2 epochs to actually persist the data. So from the time you make these queries, expect some delay up to 20 minutes until you can actually see these changes reflected in your canister status endpoint. It's also important to note that there's a possibility for under-accounting, since we take the median. If, for example, a canister traffic is so low that that we don't even hit half of the replicas within one of these epochs, the median will come out as 0, even though there has been some traffic. Next slide, please. Here I have a little demo canister that is essentially a dashboard of itself, of its own instruction counter. And I can quickly show how this is implemented. So it's essentially what I just showed in the slides. I have a periodic task that calls this canister status endpoint and then records the query statistics into this vector queue here. And then I have a instructions query call that queries the last 60 records from this vector queue and serves it back to the front end. And then I won't show the front end code because it's kind of trivial, but essentially the front end just then draws this this nice graph here. And if we are lucky, we can actually see the value increasing because querying, like updating this chart itself, creates instructions, query call instructions. This should be reflected in the statistics at some point. For this example, I have reduced the epoch length to 1 minute so that we actually might be able to see this in this demo. So I will just continue clicking update, and hopefully within like a minute or 2, we might be able to see changes in this graph. Yeah, so here we see that me just updating this, basically re-requesting this this graph again and again, has increased the instruction counter. I have also included the other statistics in the tooltip, so you can actually see that also the other statistics have been updated. Yeah, and that's the demo. Yeah, the changes in the CDKs are already published, so you already have these fields inside of the canister status endpoint. They will be default to 0, but you can already start implementing if you want. This feature will be soon activated in DFX, so you can see that this works for yourself. Mainnet rollout is planned in the next month. Yeah, and that's it. Many thanks to Stefan Kessler, who was the research lead and co-implementer of this feature with me, Stefan Schneider, who helped us on the state management side, Venkatesh Sekar, who did the security review, as well as consensus and runtime teams for their feedback and MR reviews. And that's it from me. Thank you very much.
Thank you, Leon. I know that this was a much requested feature, so I'm pretty sure the community will be happy that we finally have it. There's some questions in the chat, so if you don't mind answering them.
Yeah, should I take them live or should I just answer in the chat?
So if you could do it in the chat, it would be better.
All right.
Since we're a bit short on time.
All right.
All right, thank you. Right, next we have NNS Neuron Sandbox from Björn.
Thank you, Saša. Yeah, I'm happy to talk about the Neuron Sandbox, which is, as you already mentioned, an interactive simulator for NNS neurons. Of course, 100% on chain. I mean, why do we need this? I mean, as you know, if you want to participate in NNS governance, you need to lock up ICP tokens in neurons. And while doing so, you have to make a couple of choices on the configuration, and you can also do certain operations on these neurons. And the idea of this simulator is really to give you a playground where you can try out all the different bells and whistles and see what happens, also the effect over time. So in the picture of the sandbox, there are a lot of shuffles around, and you can build and construct as you wish to see how that goes. I mean, how it's done, it's implemented in JavaScript in a dedicated canister. And you will see in a second, there are a couple of interactive tiles where you can trigger the simulations. And there's always then also for every tile a pop-up, which gives you some more detailed information if you want to understand the underlying methodology in more detail. And the tool has been shared already with the community and the forum. I'm now looking forward to feedback. And with that, I would like to come to the demo. So this is the interface of the Neuron Sandbox. So let me walk you through tile by tile. So on the upper left-hand side, you have like this staking tile where you see the neuron comes with 100 ICP filled in. You see also like here you have maturity, which reflects the amount of voting rewards you already collected. Since we are at the start of the simulation, there are no voting rewards around yet. And so the first thing I'm going to do now in this middle tile here is I'm going to set the dissolve delay, so essentially the lockup time of the neuron. And since I'm a bullish supporter of the internet computer, of course, I'm going to take the maximum, so 8 years. So immediately I become part of the 8-year gang. And as you see, also as a consequence, the dissolve delay bonus that is now linked to this neuron is 100%. If you want to understand more in detail how that works, you can click on this little info button. And then you see you have this chart coming up and a little info text that explains how this dissolve delay bonus is calculated and some further details. Now, yeah, I'm ready now to start the simulation already. So I click on the start button on the upper right-hand side. And now you see like the neuron is sort of gaining voting rewards over time. It's in dissolve state, non-dissolving. And because it's non-dissolving, let me pause it for a second. It's also accumulating age, which precisely measures the time the neuron is in this non-dissolving state. And when you accumulate age, you also benefit from a concept age bonus. Again, if you want to know more about this, you can click on this little info button, and that explains how the age bonus is calculated as a function of the age of the neuron. Now, yeah, many people in the forum ask, okay, so what precisely happens if I start clicking this dissolve button, which essentially starts a kitchen timer until the neuron is dissolved. So I can do that here, right? I click on the start dissolving button, and you see now the state of the neuron changes to dissolving. And all of a sudden I have an age of 0 and also an age bonus of 0. So that's in a way lost. Now I can continue the simulation, and you see also now, given that the neuron is dissolving, the dissolve delay is counting down over time. And here also in this pop-up diagram, you can observe then how the dissolve delay bonus then is changed according to this decrease in the dissolve delay. Now I can stop dissolving and sort of start to accumulate age again. Another question that sometimes pops up in the forums is like, okay, so what precisely happens if I top up a neuron? So let me quickly pause simulation roughly at, say, when the neuron has an age of a year roughly. So roughly here. Now I can, for example, here increase the amount that is staked in this neuron. So I put in another 100 ICP here. And now look at the age, what happens if I confirm. You see like this age is now halved, and that's because the new age of this topped up neuron is calculated as the weighted average of the existing ICP, which had stake already, and this freshly new ICP, which did not have any age yet. Now I can continue the simulation, and let me come now to the remaining tiles here. So like this new neuron, of course, now has voting power, which allows me to influence decisions in the NNS. And you can see here in this graph, voting power over time, how the voting power changes. So we started with a stake of 100, had a dissolve delay bonus of 100%. Now that's why it starts with 200. Now you see like initially like this voting power increased over time, and that's because the neuron accumulated age. Then I click on the dissolve delay button, and hence you see a little cliff in this chart where I lost this age bonus. And later on, you see also, again, a bigger increase. That's why, because I topped up the neuron and now I have more stake and hence also higher voting power. Similarly, I think many people are interested in, what are the precise rewards that I sort of follow with certain strategies. So I mean, like you have here like this maturity field, which sort of gives you an estimate of what your reward is going to be over time. And if you want to have further details, you have like this reward graph on the top and top right-hand side. Again, if you want to have more details, there's like a popped-up diagram which explains you how the reward pool is calculated, which involves a voting reward function and also the allocation of the reward pool to neurons. We can't go into detail here, but you can check it out when you try to play with the tool. And you can also see like how the rewards really change over time as a reaction to your configuration and actions on the neuron. Yeah, I mean, of course, you can try out some different scenarios here. You can also reset the tool. And one thing I want to point out is like there's also like this expert setting menu. On top right-hand side, you can, for example, choose the start date of the simulation, which actually influences the amount of voting rewards you will get. And you can also define the simulation length. And you can also define breakpoint frequency if you wish. For example, if you say want to trigger a certain action every 1 year, you can specify that here and hit the precise time when you want to execute something. So like I have prepared two little operations that I want to quickly show you. I wanted to compare two strategies because that's also a theme that often pops up on the forum. Let's say I have a certain amount of ICP. I want to stake it, have it liquid again in 8 years. What's the best strategy of what I should do with it? And strategy A could be, well, you lock it up for 8 years and start dissolving immediately. Strategy B could be you lock it up for 4 years, for example, and you accumulate age for 4 years, and then you start dissolving. Now, with this tool here, you can really compare and see what happens in a very visual way. So like this now tab here shows you the simulation for strategy A, and you see, you get actually over the course of 8 years, like a maturity of 105. If you now choose strategy B, the picture looks very different in terms of the graphs, but the result actually is, in terms of maturity earned, is not much lower, but a little bit lower. So yeah, you will get a feeling into how you can actually execute and compare different strategies. Yeah, this is the Neuron Sandbox. Please check it out. I'm looking forward to your feedback. The link to the tool is on the left-hand side. And there's also a forum post where people can leave comments. Yeah, I hope this is going to be helpful for you, and I'm looking forward to your feedback. Thank you so much.
Thank you, Bern. I wish we had this at the launch time. It would answer so many questions. Thanks. You have a lot of questions in the forum. If you could answer them,
I will have a look. Yeah, thank you.
Yeah, thanks. Thanks. All right, let's jump to the next section. Timo.
Thank you, Saša. So the HPL is a ledger that can process 10,000 transactions per second, where one transaction is an individual ingress request. And the HPL is also a multi-token ledger, which means it can host an arbitrary number of different tokens. We do this to showcase the capabilities of the IC. And because all current IC ledgers by design, by single canister design, are limited to somewhere less than 1K TPS. 10,000 is an interesting and also challenging number and happens to lie somewhere between the Visa network's average and peak load. As a multi-token ledger, the HPL can also offer things like atomic swaps, and of course has an advantage because if you integrate it with something or audit the code, then you've essentially done it once for all the tokens that are hosted on it. We achieve it by moving from a single canister design to a canister system, which consists of aggregators, multiple aggregators, and one ledger who all live on different subnets. Next slide, please. So the way this works is that a user submits his transactions to a randomly chosen aggregator, and the aggregator sends one batch per execution round to the ledger. The user then can query or queries in a certain pattern, both aggregator and ledger, until the final confirmation is received. And for the batching, we have an efficient streaming protocol, meaning that we have TCP-like guarantees and that the batches can be pipelined. Next slide, please. So let's look at the limits that are in place. This has a limit of somewhere less than 1,000 ingress messages per second, which means that for our goal, we need at least 10 aggregators on 10 different subnets. Maybe with some margin, better to have 20. Queries should not be a problem and can be directed directly at the ledger. Next slide, please. All the batches of all the aggregators combined ultimately have to fit into 2 MB of block space, which is available every second at the receiving subnet where the ledger lives. We are assuming a 50 bytes per transaction, which gives us the limit shown. Next slide, please. On the execution side, we have a limit of 2 billion instructions, WebAssembly instructions per second, and 20,000 pages that can be dirtied. Our data structures are all designed for constant time access, and we have a budget of 50,000 instructions per transaction, which gives us the shown limit. And for the dirty pages, each transaction necessarily has to dirty 2 pages, 1 page where the sender's balance is stored and 1 page where the receiver's balance is stored. So that is the bottleneck in the whole design. And we're right on target with 10K here, which, by the way, is a total coincidence. We didn't know this limit when we set our goal initially. Next slide, please. We've done a lot of experiments where we actually reach 10K, more or less sustained or get close to it. We've also done experiments where we remove certain bottlenecks. So, for example, artificially bypass the ingress bottleneck and craft the transactions so that we hit the same WASM pages all the time. But the cross-subnet communication is still real, and the execution instructions are also real, and we can hit 40K like that. We also measure the end-to-end latency for the user from the point of submission to final confirmation in the wallet. And it lies somewhere between 4 and 5 seconds, even with the 95th percentile. This number has come down nicely by about 1.5 seconds by the latest P2P rollouts that happened. Next slide, please. In terms of software components, there are a few more. We need, for example, a multi-canister archive to store the transaction history. We have a separate Minter canister, which can bridge all ICRC1 tokens onto HPL. We have a token directory, which hosts curated metadata about the assets in the ledger. Most importantly, unique symbols, the token symbols. And then we have an RxDB canister, which the wallet can use to sync its contact book, for example, between different browsers and different machines. Next slide, please. Before we can go to the demo, one word about the transfer model. We use allowances for everything, meaning for both directions, both for pull payments and for push payments. And we call that a personal exchange link. So for 2 parties, A and B, to transfer between 2 accounts, one of the parties, let's say A, has to create a link it to one of its accounts, and personalize it for B. And then B can use that personalized link and pull from it or push to it. So on HPL, it is not possible to transfer between 2 accounts directly if they are owned by different parties, unless a link is involved. Okay, now we can go to the demo. And here we can go to the settings and we see where Alice can configure her directory canister. She can use a service she trusts, or she can host her own. We see that Alice already has 2 accounts for 2 different tokens, ABC, and some wrapped version of CKEs. We can also look at all the assets that exist in the ledger. Here, the subset of the ones that are actually defined in the directory. The information in the table is here divided by information that comes from the ledger, from the directory, and from the wallet. We see, for example, that the directory links a token with symbol ABC to the asset ID 0 in the ledger. Asset ID 0 is controlled by the anonymous principal, which means anyone can mint this token. There's a certain total supply floating around at the moment, and some of the supply happens to be owned by the ledger itself because the ledger has collected it as fees, 59 tokens here. We see here, this is the one account that Alice has for this asset. Now we right away here, we can open a second account. Opening account is actually a call to the ledger. And we can show how Alice can send tokens to one of her own accounts. So here, no link is required. You can transfer tokens between your own accounts freely. Let's see how long it takes. 4.8 seconds. Now let's show how we can transfer between different users. So Alice in her contact book already has a user, Bob. And to give tokens to Bob, she can, for example, take her main account, create a link, make it accessible by Bob, set a balance, that an amount that Bob can draw. Adding this link is again a call to the ledger. Then we can switch to the other tab where Bob is already logged in. Bob already has an account for the same token. So he can click on pull. Well, he needs the link code. So Alice copies the link code for the link she has created, sends it by some channel to Bob. Bob pastes it in here, sees the balance available, and can draw, for example, the maximum amount into his account. As completed, his balance has gone up, and let's see what Alice sees. If Alice refreshes her balance, she sees her token amount gone down, and also the one in the link is now at 0. Now let's do a push payment. So how can Alice allow Bob to push tokens to her? Again, she creates a link like she's already done. Balance can be the initial balance 0. She copies the link code, sends it to Bob. Bob chooses an account that is funded, clicks on send, now pastes the link code on the receiving side, chooses an amount. So for example, if you enter in the field down here, then you're defining what the receiver gets exactly. So that's sender pays versus receiver pays for the fee. Now let's see how Alice sees the payment that is received. She has to refresh her balance. And now her balance has gone up here, and she sees that it came through this link, these 100 tokens. So now to finally accept this payment, Alice has to reset the balance to 0. That is what makes the push payment from Bob irreversible. If she does not do that, then Bob could pull the 100 tokens back if he wanted to. Now, finally, I also want to show how we can mint a wrapped token. Alice, we see, has some CKEs here in her ICRC1 wallet. This is the Minter dashboard. The Minter actually offers CKEs to be minted. Now, Alice has to create a sub-account at the Minter. Has to add the Minter to her contact book, the asset that she wants to mint. Something. Asset something broken. We have to skip the minting process, but there's a seamless way to mint any ICRC1 token onto the HPL ledger and obtain a wrapped token like this one here. All right, I'll pass back. Thank you.
So this sounds very exciting, Timo. I'm wondering if the source is gonna be open to everyone, or are you gonna allow others to?
Of course, it's an open source project. However, we are releasing it slowly, only if it's mature enough.
So now, next we have the community demo from Helix Markets. It's the last section.
Yeah, good afternoon, everybody. My name is John. I'm one of the co-founders of Helix Markets. Helix Markets is a relatively new DEX that's built on the internet computer. The team's been building on the internet computer for about 18 months. We wanted to showcase a lot of the features, that the research team has been developing, and we hear about it and stuff. But when you see it in application, then you sort of get this sort of aha moment. So where you're making use of threshold UCDSA to do the native swaps, the reverse gas model to sort of handle all the gas, so the user doesn't have to do it. So just to give a user a very clean experience. So if you haven't given it a try, please give Helix Markets a login. But for today, what I wanted to talk about was the SDK that we're about to release. The way we designed Helix Markets was that we wanted to, trading bots and market makers to be able to run various strategies programmatically. So it's based on WebSockets, which is Web 2, but it opens up all the traditional strategies, and this is what I'll start demonstrating. So if you can, but the idea that it provides an entire functionality on the exchange. You'll be able to do deposits, transfers, and all the trading functionality. The first version of the SDK will be fully Python, and then I'm getting a bit of help from ChatGPT to sort of port that to Rust, TypeScript, and C#. We're going to make the first version of that available in the middle of March. So I'll just jump straight to the demo. To a configure file, you can make the exchange, log into the exchange and do. In this example, we're doing a TWAP, and TWAP means a time-weighted average price execution, right? So what I specified here was to do specify selling, to do a sell of ICP USDC, do it for a duration of 1 minute, and I want to do it in equal 10 intervals. So it works out to be 6 seconds. It will do a total of 10 ICP. And it'll in 10 different intervals. And then at the end, I also specified that I wanted to send that the proceeds, which is in USDC, into my what I hard coded as a Trezor Ether wallet that I've preset. So when you're ready, let me just make sure I have all the screens and stuff that ready. So this is the login screen in Helix. This is your sort of dashboard. Where you see your initial or your balances. Right now, if you look at the ICP balance, there's not much right now. So when I wanted to go sell 10, so to start the program, you just type Python run, Helix TWAP, and what it'll do, it logs in with the API, it knows the user ID, and then it says, it looks at the balance, says you don't have enough balance, please send 7.91, that's the missing balance to get up to 10. This is your principal ID, and then your account ID. And then, then if I go to my NNS account, where I go and, before I do that, let me just get the address. So that's the principal ID for the Helix account. And then I go to NNS and I hit send, and put it in the address, and then let's just send 10. And then hit send now. Okay, and then you see it's picked it up. The exchange has picked up that there's a deposit into your account. And what we have this, when you look in Helix, we have the two wallet concept. It's very similar to Binance, where you have a funding wallet, where it's segregated, and that's where you make all deposits. And then when you want to trade, you transfer it to the trading wallet. And that's what it's doing right now. It's picked up the deposit and it's transferring the to the trading wallet, where you can start making execution orders and stuff like that. So this is all on chain on the transfer. And when this completes, I will actually show it to you, the ledger transaction. So hopefully it'll show up soon. Okay, there you go. And then, yeah, so then you can sort of see it, that it's that it was a transfer. See, now the bot sort of said, okay, I have the balance now, so I can start executing and type anything. It says done. So this is, if you go to the order book where it starts executing, this is where I said it does a transaction every 6 seconds, because we said 10 intervals, where it does a total of 10 ICP. You can see it's this is the order book, where the market, so other market makers are on there providing the liquidity, and you're just using that liquidity to do your TWAP. And the TWAP, you can specify to do any, you can actually even do it over a week period and stuff like that. It's all in the algorithm that you want to make up. Okay, so now it's done 10 out of 10 transactions. And then it gives you a summary of all the transaction, your proceeds of the 10 was $129. There's a commission, it discloses this commission. And now what it's doing now is it says, okay, the trade is done. And then I'll move it from your trading wallet back to the funding wallet. And if you sort of want to watch that, you can watch the transfers that are happening from the transfer. Yeah, so this is a bit faster now. So again, and what I did on the config file was to transfer it to my USDC wallet, which is actually on my MetaMask. So if you look at this sort of MetaMask, right now there is no USDC balance. So if you wait a bit now, see, it's done the transfer between the trading and the funding wallet. Now it's going to do the actual transfer. And this is where it does it on the Ethereum network. So if you can see it, it says it's going to send it to my Ethereum address 0x, which is tied to the MetaMask wallet here, and then hopefully you'll see it. Right. So, oh, another failure. Oh, we're getting a lot of failures today. Okay, that wasn't good. Insufficient funds for gas. Oh, okay. Hang on. I thought I had. This is the good old Ethereum problem, but I thought I had more than enough Ether. Well, 66, and it still didn't go through. So, oh, okay, that's real. What happens when? So you can try to do it again. Holy smokes! Yeah, this is what happens when you. So I said there's definitely a showcase of working on a chain that doesn't have a reverse gas model. But if but there's actually a video where it actually goes through. I can post a link on YouTube. But the idea, it does make it to your MetaMask account. It does show up. I can show you one because I was doing it earlier today, just to make sure it works. But it always works when you're not doing a live demo. So I actually did a real withdrawal on Ethereum. Where did it go? Yeah, this one. The withdraw USDC. Yeah, so I was doing this earlier. And it does show up. You can look it on the Etherscan. It eventually does show up on your MetaMask. Yeah, maybe next time it will be. But yeah, do have a look at the video. It does work. And yeah, I mean, we're going to release the SDK mid-March, and give it a try, and hopefully you can do all this programmatically.
Thank you very much, John. So I think this will greatly help to increase the liquidity on the Helix market. So that's great. Great to have that. All right. So that's all for tonight or today. Thank you all for attending. Lots of great demos, lots of good updates. You can watch this video on YouTube later on. And thanks everyone for attending. See you next time. Bye-bye.